Hello everyone, welcome to this new session of Newton's Law of Motion. My name is Anshul Jindal and I am physics faculty in Sri Chaitanya Gosala branch, Vijayawada. Right. So today we will learn about one of the most important chapter of the complete physics, or you can think it like as a foundation of the physics. Yes, you heard it right. It's a foundation of the whole physics. Without this, you cannot understand any of the chapter, right? Yes, we are talking about the chapter Newton's Law of Motion, right? You have already done this in your class 9 as a chapter name, force. So we are going to learn again the same thing but in the detailed manner, right? So today we will start with only very small concept, only one law of this Newton law, that is first law, and few basic things related to the chapter and few history related to the chapter, right? So let's start with the chapter. I hope you will enjoy the session today, right? Okay, so let's start with one example. I'll give you a few examples and you tell me why this is happening, right? How this is related to the physics laws, right? So I show you few slides here. So you can see here a man is falling and all of a sudden, see here, these all leaves are at the same place but the man moved down, right? You can see here, right? So the question is why this is happening, why this is happening. We need to understand the reason behind it, right? You can see this video, right? Let's see another one. Okay, you do one thing, you keep one cardboard and over that cardboard you keep one coin and just remove the cardboard. All of a sudden when you removed it, you see that the coin will fall down. It will not move with the cardboard, right? So the question is why this is going to happen, why this is happening. So you can try this now only, right? So just take any glass, keep one cardboard over that and keep one coin and just remove the cardboard. You can see that the coin will fall down. The question is why this is falling down, right? Next one. See, this is a very basic one, right? All of a sudden when a car moves or a bus moves, you fall back, or anything kept in front, these also fall back. So the question is again, why these things are falling back, right? Why these things are falling back? Yes. This here, the example of the bus, people standing in the bus, all of a sudden some brake is applied, people fall back, or it is accelerated, people fall back, and when the brake is applied, you move forward, right? So the question is why this is happening, right? So to all these questions, right, today we will try to understand the reason behind it, and who was the person who had given the reason or the laws to explain all these things happening around us, right? This is happening long before, right? It's not about Newton is someone who after explaining the laws only these things are happening. No, it is happening long before, right? From the starting of the universe, these things are already there, right? But the thing is, the Newton was the first person who had given the reason or the way to explain these things which is happening around us, right? So let's understand, what is this? So you might have heard Newton had given the 3 laws. Yes, Newton had given the 3 laws. Of that, we'll today discuss about the first law, right? So what is that first law? Everyone knew about it. What is that first law? The first law is, if a body is in rest, just like this pen, it will remain at rest. If I roll the pen, it will keep rolling on the frictionless surface until and unless if I don't apply any external force on it. I repeat it again. What is Newton's first law? Newton's first law is, if a body is in motion, it will remain in motion. If a body is in rest, it will remain in rest until and unless you are not applying any external force on it. If a pen is at rest, you need a force to move it, right? You need a force to to make this body in the motion, right? So that's what the Newton first law. Key, if a body is in rest, it will remain in rest. If a body is in motion, it will remain in motion until and unless what? External force is not applied on it, right? So that's a very simple statement, the first. And we also name this as a law of inertia. I'll explain you this later, okay, why this law is termed as law of inertia. And here is one term. Here is one term for here, this inertia. This inertia. So we'll try to understand this. Okay, what is this inertia is? See, I'll again read the statement. Every object will remain at rest or in uniform motion in a straight line, compelled to a change its state. That's the same meaning what I have explained. Okay, a body will remain in rest or state of motion until and unless an external force is not applied on it. Right? Right. Yes, that's the first law. So let's understand this. Okay, how this first law is related to the example what we have discussed. Yes. So see, I'll start with this example. See here, the man is falling. Is this man is applying a force on these dry leaves? No, the man is not applying any force on the dry leaves. The man is applying force on this net. That's why the net moved down. But after certain time, you can see that these leaves are also falling. Why? The very simple reason is the gravity, right? Because of gravity, they will going to fall down, but not all of a sudden. Right? So that's what Newton said, ki until you will not apply force on them, they will not fall. Right? They will remain in rest. They will going to stay in rest. Right? Why? Because we have not applied any external force. Right? That's an impulsive force. A man fall and all of a sudden the net moved down. But they are not applying any force on the dry leaves. Right? So that's a very simple. Let's understand the next example on the basis of this. Here you can see this cardboard. We are applying force on the cardboard. Yes, we are applying force on the cardboard, not on the coin. So if I have a cup and if I keep a cardboard and a coin, if I apply force on the cardboard, the coin will fall. Given that your cardboard is frictionless. If there is a friction, then some force will be there on the coin due to friction. I don't want that. Right? So the coin will fall down because there is no force in the horizontal direction. Yes, there is a force in vertical direction. Yes, there is a force in what? Vertical direction, but not in horizontal direction. That's why your coin is falling down. Yes, the coin is falling down because there is a one force in which direction? Downward direction. But there is no force in the horizontal direction. There is only a force in the horizontal direction on what? Cardboard. That's why cardboard is moving in the horizontal direction, but your coin is moving in which direction? Vertical direction. That's what the Newton said. In a particular direction, if I am moving in this direction, right, I want to change the velocity of my body in this direction, I want force. If I apply my force in this direction, will my velocity will change in this direction? No, my velocity will not change in this direction. If I want to change the velocity in this direction, what I required is one force. That's what Newton said according to first law. Key, if a body is in motion, it will remain in motion until and unless external force is not applied in that direction. Until and unless external force is not applied in that direction. Right? That's a simple meaning. Guys, let's understand the next one. Yes, here, that's the same thing. Right? What happened? These objects are placed and it's almost frictionless. When the car moved, so we had applied force on the car, not on the object. So the car moved forward, but the object are still at the same place, right? Although we are in the car, objects are not moving. See, your car is moving, but because we are in the car, it feels like objects are moving back, but they are not moving back. Actually, your car is moving forward, and because of that, see, it's the same thing. If I move my hand forward, what will happen? This pen will fall down, right? With respect to pen, your pen is moving backward. That's what happening in the car. Your objects are not moving backward. What is happening with relative to the car? They are moving backward. But in general, actually what is happening? They are at the same place. Your car is moving forward. Your car is moving forward, right? I hope you are getting this. These all examples you can relate, right? Okay, what actually the Newton's law is? What actually the Newton's law is? Okay, if a body is in motion, it will remain in motion. If a body is in rest, it will remain in rest until and unless external force is not applied on it, right? Okay, let's move next. Let's move to the next point. Yes, it's the same you can define, right? Again, same like these people, this is nothing but the objects. These are the objects. So as your car move forward, they are at the same place. So with respect to car, with respect to bus, they will move backward. They will move backward, right? So that's what is happening. That's what. Even when you hold the pipe of the bus, so what is happening? The force by the bus is applied on your hand, not on the complete body. So your hand want to move forward, but these two are connected. You are not applying force on the body. That's why you feel jerk. That's why you feel jerk when all of a sudden a car or a bus is moving forward, right? So that's a simple reason we can explain on the basis of Newton's first law. On the basis of what? Newton's first law, right? So let's move to next. Let's move to next one. That's the whole story, right? So let's move to the history. Okay, from where this whole story started. A long back, Newton had written one book, right? That's a screenshot of the book. Here, see what he had written. It's a way, right? So every body preserves in its state of rest or of a uniform motion in a straight line unless it is compelled to change that state of form by a impress theorem. That's the same statement. It's a slightly tough language, right? What I have explained, they have written the same thing in slightly difficult language, right? But this is the first time this Newton had given something in written about the Newton's law. See, it's not an outcome of a single day, right? Newton did lot of research over it, right? And after that, he had written the whole book. He had written the whole book, right? And from this book, now we are learning. And this is a foundation. Newton had given the foundation of the which type of physics? Classical physics. We name this as what? Classical physics. What we are learning right now is classical physics. One is quantum physics, right? We are not going to deal with the quantum physics in class 11th and 12th. We are only dealing with what? Majority times, right? Sometimes we're going to deal with the quantum also, right? But majority time we are going to learn the classical physics, right? And classical physics is not the only outcome of the Newton's law, right? There are so many things. By the time you will learn all, but Newton was a person who laid the foundation of the whole classical physics, right? Okay, let's move to next. So what happened before Newton? People assumes that Newton was the only person who had given statement about all these things around us, but that's not the truth, right? There are so many persons. One is Aristotle. Yes, Aristotle said that all objects have a natural place in universe. In the whole universe, every single object have their natural place. They are in the rest, right? So he said that he observed the things around him, and according to the observation at that time, Aristotle time, right? He had given that statement. He had given, just like he explained this thing by the way of stones, in the flow, in the bed of the river, the way the stones are arranged. right? They have their some place, so you can assume it like a universe, and these stones have their own place, right? So that's how he defined it. Key in this whole universe, every object have their own natural place, right? Just like these stars will also have their natural place. So what was a actually complete statement of the Aristotle? Aristotle said all objects have a natural place in the universe, and what is that natural state? Although he was not correct, right? And he was not correct. He was not 100% correct, but yes, he also had observed the same type of things, and on the basis of observation he said all the objects have a natural place in the universe, and the natural state of any body is rest. Natural state of any body is what? Rest. Yes. So yes, see now, is it possible that without applying force this body can move? Is it possible? Is it possible that a body can move without a force? No, it's not possible, right? So on the basis of these small observation, he said that the natural place of all object is what? Rest, right? That's why he said this. Yes. Even Galileo, the very famous name, right? Very famous name in the gravitation field, right? So he also said the same thing, right? A force is necessary to change the velocity of the body. Yes, that's what Newton said. Right? Newton said the same thing but in the different way, right? So the force is necessary to change the velocity of the body, but no force is needed to maintain its velocity. Just think it like this. Okay, let's assume you have one frictionless floor and you had rolled some body. What will happen? It will keep rolling for the infinite time if you have 100% frictionless surface. That's a different case. We don't have such type of surface in our daily life, so it's very difficult to get such type of result. But if you can imagine, if we have a frictionless surface, then what will happen? If you roll the object, what will happen? It will keep rolling for the infinite time. That's what the Galileo said. No force is needed to maintain its velocity, right? Or in the absence of force, the body will keep moving. In the absence of force, the body will keep moving. Right? So it was a misconception that the Newton was the only person who had given some theories about the mechanics. No, but yes, Newton was the first person who had given all the laws in the proper format and detailed version, right? He had proved, he had given all the theories with all the supporting examples, right? Before that, Galileo was also there. Before that, Aristotle was also there, right? So Newton was not the first person, but yes, Newton was one who had given the Newton apple. Yes, you all have heard that story. Okay, one day Newton was sleeping just below near the tree, and what happened? So because of some wind and something, one apple fall on him, and from there all this story started. But this is not the case, right? Yes, this was one of the proof for him, but yes, he was thinking about this thing from a very long time, right? So that's what it is. Okay, Newton's, that's why we name it as a Newton's law of motion, not Galileo or Aristotle, because they had not given the detailed version of this, all these things, right? So Newton's law of motion, we all know that. Okay, how many laws Newton had given? 3 laws, right? Aristotle had not given all these, right? Your Galileo had also not given all these laws, right? But Newton specifically has defined everything, and Newton had given 3 laws, right? So today we will going to discuss about one single law, right? If you have understood these 3 laws, right, so you will be going to understand the whole physics very easily, because everywhere in the every single chapter we will be going to use all these three laws, right? Whether it is from your class 11th or you're from a class 12th, right? Okay. So now coming to the point. So I have told you the first law, just now what we have discussed was the first law, right? What we name this? We name this as what? Law of inertia, right? So now the question is, what do you mean by inertia? The question is, what do you mean by inertia? So let's see, what do you mean by inertia? Okay, let's take one example of our daily life. When we are sleeping or when we are watching a movie, and that movie is very interesting, and all of a sudden your parents, your mother or your brother or sister, they ask you to do something, what will happen? You resist, right? And if the movie is more interesting, right, you will resist more, right? So that's what the inertia is, the capacity to resist against the change, the capacity to resist against what? Change. That's the inertia of the body. That's the inertia of the body. I give you one more example, right? Let us assume one elephant and one rat is coming towards you, right, with some velocity, right? What you will do? If the elephant is coming, will you try to stop it? No, because the inertia of the elephant is what? Huge, right? Because the mass of the elephant is what? Huge. But if the rat is coming towards you, with respect to you, inertia of the rat is what? Very less. Inertia of the rat is what? Very less. So what will happen? You can easily stop him, right? So I can say that inertia is nothing but what? Capacity. It's a capacity to what? Resist against what? Against what? A culprit. Who is a culprit? That's a force. Force is someone who will going to change your state. If you are at rest, it will try to move. It will try to make you in motion, right? If you are in motion, it will try to, just like you have a car, you apply brake. So you apply brake to reduce the velocity. You apply accelerator to increase the velocity. So this is what the force. So force is something which is used to change the state of your body, right? So he is a culprit. So capacity to resist against culprit, that's your what? Force. And force is one who is trying to make all changes, right? So that's a factor, right? So that's inertia. So what I said, inertia is directly proportional to what? Mass. Inertia is directly proportional to what? Mass. I hope you understood this point. Okay, what do you mean by inertia, right? So who will have a more inertia, elephant or a rat? Elephant. Yes, very simple reason. Yes, very simple reason. Right? So it's a very simple reason. The body will have a more mass, so I can say inertia of elephant is more than inertia of water, right? So now on the basis of this, we divide inertia into three factors, three different type of inertia, right? One is inertia of rest. Yes, very simple. If one heavy object and one very small object, in which case you will have to apply more force, in which case you will face more difficulty to move the body. It's a very simple reason. It's a heavy body, heavy body, we require more amount of force. So we can say that this type of inertia, this type of capacity to resist against the force In the case of water, rest is termed as your water inertia of a rest. This termed as water inertia of water rest, right? Let's move to next one. That's the next one is inertia of motion. That's the next one is what? Inertia of motion. Just now I have given you example. If a truck is coming towards you and one bike is coming, in which case you will apply more amount of force. Obviously in the first case you will run away, right? Why? Because the truck is very large, you don't have this much capacity. So inertia of the truck is more. But this thing we are right now talking about rest or motion. So this property of the body in the state of motion is termed as water inertia of water motion. This is termed as water inertia of water motion. Right? I hope you are you getting this? Okay, there are two things right now we have discussed. Same body, same mass, but right now if I am standing, if I am at rest, I have an inertia of rest. If I start moving, then in this case my body will have what type of inertia? Inertia of motion, right? Same thing. Now we have what? Third, inertia of direction, right? When you are riding a car, right, you want to take a turn, right? So what you do? You turn your steering, you apply some force, right? And if it is a truck, you need more force, right? So that's what the inertia of direction. Ki more the mass, more force you required to change what? Direction. Are you getting this? Are you getting this? Right? So what I said, ki we have three inertia. Let's first discuss about the inertia. What is inertia? Inertia is the capacity to say what? No. Or it's a capacity to resist. It's a capacity to what? Resist. Against whom? It's a capacity to resist against someone who is trying to change your state. If you are at rest, force will try to move. If you are moving, force will try to increase your velocity or decrease your velocity. It means it is changing your nature, right? It's your inbuilt nature. You can assume it like if you are moving with a 30 meter per second. So that 30 meter per second is your property. If you want to change it, you need a force. You need a what? Force. So that's what it is. It's a inertia. It's a inertia. And we have three types of inertia. What we said? Inertia of rest, inertia of motion, and third one is what? Inertia of what? Direction. I hope you are getting this. And I have told you one very important thing. Inertia is directly proportional to what? Mass of the body. More the value of the mass, more the inertia body will have. More the inertia, yes, body will have. So that's what. That's what. See, one example here. A man was moving and see, he tried to move rightward, but he cannot because the road is very slippery. And because of the inertia, he was moving and he will keep moving because the inertia of the body is very high. That's why he keep moving. Right? Are you getting all this? Okay, what is happening here? How the inertia is working here? And how this, that's why we name this as a first law of inertia. Right? Your first law is related to what? Inertia. Your first law is related to what? Inertia. Yes. Yes. One more example. That's a very simple. You can see all of a sudden when we apply brake, right? You collide. Why? Because you are moving and all of a sudden you apply brake on the car, not on you, right? So you are still in motion, right? So again, as per the inertia, you will keep moving. And all of a sudden what will happen? You will fall. Right? So that's what it is. Right? I hope you all got the point. Okay, what is this all about? So it's a very simple today's lecture, right? It's all about Newton's first law only, right? And it's only about the inertia. Let's recap everything and then we'll close the session for today. So what we had done, we had started our chapter with the first law of inertia by giving some example okay, how body is in motion, remain in motion, body is in rest, remain in rest until and unless external force applied on it. And then after we have explained this law with the help of few examples, and after taking some example we have discussed about the one important word which is nothing but what? Inertia. And inertia are of how many types? 3 types, that is your rest, motion and direction. And I had tried to explain those things with the help of what? Example, that how the body having a more mass have a more inertia at rest, same thing with the motion and same thing with the direction. I hope you have understood every single word I have explained here, right? And one request to everyone, right? If till now you have not liked my video, okay, and you have not subscribed the channel, do it now and just write it down, done, in the chat. Okay, see it in the next lecture, right? Till now, keep studying, keep your motivation high. I'll meet you next time with the same chapter, with the next what? Law of the Newton's law, that is Newton's second law. See you next time. Thank you.